Assalamualaikum warahmatullahi wabarakatuh. My name is Roshada binti Ismail. My metric number is CE190182. Basically, I'm the one of my team member A4.4 group. This is our team members. Me, Roshada binti Ismail, as our first presenter. The second presenter is Nikno Faika binti Tamin, DE190116, and our last presenter is Naziha binti Zainuddin, DE190149. So basically, I will explain as question number 1, number 2, and number 3. Okay, so for the question number 1, the question is said, function of EFR, current and time setting. This is the figure of the earth fault relay is a type of relay that can be sensed the faults between the phase and earth. An EFR primary function is to detect leakage currents to the ground. These relays have the ability to detect higher fault currents. Thus, EFR is used to protect the equipment. High current flows to the grounded neutral of the transformer when there is a phase to ground fault. Typically, its input is provided by an external CT and its output is delivered to any breaker, such as MCCB, which performs the tripping mechanisms. So, an EFR is monitoring device that receive input from a CT and outputs to a breaker. As a result, when the fault is detected, the EFR trips the circuit breaker. Ada question for question 1, the current setting in EFR. The current setting is the value of current set for relay trip when fault current crossing equal to or exceed the value of current set. And for time setting in EFR, time setting is the adjustment of traveling distance of EFR after fault current crossing the current. Okay. Second question, connection of EFR to CT, busbar, and MCCB. Okay, first for the connection EFR to CT. Okay, so for CT, pin number 2 will connect to the input supply of the CT, while pin number 7 is connected to the ground. Okay, second, connection EFR to busbar. Okay, for the connection EFR to busbar, pin number 1 is connected to the red phase of the busbar, and pin number 8 will connect to the neutral phase of the busbar. Okay, for connection EFR to MCCB, basically pin number 3 is connected to the auxiliary supply, while pin number 5 is also for EFR switch but connect to the neutral. Okay, last question, function of CT, busbar, and MCCB in the circuit. Okay, for CT, the fault can be detected by EFR. CT will help to determine the fault. CT will be connected to an EFR, so if the current that sent and received is same, then there won't be any induced EMF in CT. If not, then an EMF will be induced in CT, and this output of the EMF will be sent to relay. Okay, for the second function of busbar in EFR, the busbar supporting frame will be adorned through a current transformer. When the fault in busbar, the fault current flow through supporting frames in arrangement. The current transformer in the adorned frame reads the fault currents, and if this fault current higher than the pickup currents, then the relay operates. And the last but not least, a function of MCCB in EFR. So we know that MCCB is a circuit breaker that protects against overload and short currents fault, and it is also used to switch currents. So MCCB trip if it detects a short circuit or an overload in the circuit for an extended length of time. It provides effective protection in applications that require discrimination, adjustable overload settings, or earth fault protection. Okay, thank you for listening. I will pass to our second presenter, Nikno Faika binti Tamin.
My name is Nino Faika binti Tamin, and my matrix number is DE190116. So I will continue to explain for number 4, 5, and 6. And number 4, the function of each pin or point in EFR for pin number 1 is It is a negative terminal for auxiliary power to supply the operation of the relay. And pin number 2 is in positive terminal and it connects zero current transformer as a sensor. And pin number 3 acts as a normally closed NC connection to the trip. And pin number 5 acts as a normally open and it is in on mode when the current is exceeding the set value of EFR. And then pin number 7 connects zero current transformer as a sensor in negative terminal. And lastly, for pin number 8, it is in positive terminal for auxiliary power to supply the operation of the relay. And then what is the function of secondary injection test set? I will refer to figure number 3. So its function are to ensure that the protection scheme's correct operation from the relay input terminals onwards is working properly with the given parameters, and then to ensure the correct operation of all linked circuits and gears in the secondary protection system, and then to decrease the risk connected with the initial testing of the device under test on the low voltage side. And then lastly, to verify that the chip unit, its associated components, and its settings or factory parameters are all working properly. And next is for the connection of secondary injection test set to the EFR. I will refer to figure number 4. And pin number 1 is at the negative terminal of 240 volt. And pin number 8 is at the positive terminal. And pin number 8 is at the positive terminal of 240 volt. And pin number 3 is at a timer, where pin number 5 is at the normally open tag for timer. And both for pin number 2 and pin number 7 is at the input of the secondary current injection test set. And that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Naziha binti Zainuddin. So today I'm gonna talk about how to perform EFR test using secondary injection test for checking the minimum current setting. So firstly, we need to do like this circuit connection where the relay earth fault connect with the secondary injection test. Then we have to make sure that CT is de-energized. So after we de-energize the CT, we supply the earth fault relay with 240 volt and we set the secondary current injection test for the current value between 0 to 10 ampere and for the voltage 0 to 240 volt AC. After that, we should increase the value of input current test until the earth fault element pick up. Then we record the data of the current test. Then next, I'm gonna talk about how to perform EFR test using secondary injection test for checking the operating time. So to do this test, we need to connect the relay earth valve and also a relay trip contact with the secondary current injection test. So after we complete connect this circuit, we need to switch on the secondary current injection test and set the output current to 2.0 IO. IO is the value of clipping current. Then, after we set the current output, we need off the test set and switch the secondary current injection test set to the test position for inject the set current and start the timer at the same time. Then we can record the data of the relay operating time after the relay trip contact is operated. Then, after we complete record the data, we need to turn off the test set and repeat all the procedure, but we change the output current to 3.0 IO to 5.0 IO. Then, after we complete record all the data, we need to disconnect all this connection.